In this notebook, we work with the abalone dataset containing 4,177 samples. The dataset includes 8 features, such as 6 learns, whole weight, and others, capturing the physical characteristics of abalones. The target variable, rings, is used to estimate the abalone's age with the formula age equal to rings plus 1.5 years. Fortunately, the dataset was clean with no missing values or duplicates, so we could dive right into the analysis and the modeling stage without needing extensive cleaning. For EDA parts, we examined the dataset structure and quality. It includes 7 numerical features and 1 categorical feature. 6. The category variable was well balanced across its 3 categories: male, female, and infant. For the target variable, rings, the distribution was slightly right skirts, clustering between 7 and 12 rings, indicating most abalones fell within this age. The continuous features such as hallway and highway and high exhibit noticeable skewness and outlier, particularly in high, which is extremely values that needed attention. Correlation analysis revealed strong positive relationships among features like learns, diameter, and shell weight. While these correlations are promising for predictive power, they might lead to multicollinearity issues that require dimensionality reduction. To process 6, we use label encoding, mapping the categories to numerical value. Outliers in the target variable were identified using the Tukey rule, and we visualize these using box plot. While these outliers could provide insight into unique samples, they might also hinder model performance, so carefully handling was considered. Move to next part, feature importance. To determine which features contribute the most to predicting the target variable, we use a random forest model, which is inherently well suited for this task due to its ability to rank feature importance effectively. The dataset was first split into training set and a test set. We use 80-20 split and scaled it using minimax scaler and standard scaler to standardize feature magnitudes. The analysis revealed that weight-related features were the most predictive of rings. Specifically, shell weight ranked highest in importance, followed by visor ring, socket ring, and hallway. These features likely correlated closely with the abalone's age due to their relationship with the organism's growth. Meanwhile, features like length and diameter and moderate influence and sex had a minimal impact. This finding aligns with the biological understanding that weight characteristic more than linear dimensions reflect an abalone's maturity, making these features critical for predictive modeling. And we evaluate multi-regression models to predict the target variable's range. The data set was assigned split into, just like I said before, 80-20 split, and the feature were normalized and standardized. These processing steps ensured that models sensitive to feature scales, such as linear regression, performed optimally. Among the model, linear regression and ridge regression stood out as the most effective, each achieving an R-square value of 0.53 and an MSE of 5.1. These models effectively expanded around half of variance in the data, balancing simplicity with predictive power. On the other hand, lasso regression performed poorly with an R square of just 0.14, indicating that it struggled to select meaningful features in the dataset. Other models like KNN and SVR demonstrate moderate performance with R square value of 0.5 and 0.41 respectively. While these models captured some patterns in the data, they did not outperform the linear models. Decision tree top flexible showed clear signs of overfitting and achieved only an R square value of 0.2. Lastly, the MLP completely failed, delivering flat prediction with a negative R square value, likely due to insufficient tuning. And this result highlights the reliability of simpler interpretable models like linear regression for this dataset, particularly when computational efficiency and interpretability are priorities. Three basic models are neural networks may require further tuning or additional data to improve their performance. So for this analysis, weight-related features are the key in predicting abalone age, which is vital for agriculture and harvesting decision. Simpler models like linear and ridge regression work well for this dataset, offering a solid baseline with efficiency and interpretability. Future improvements could focus on handling outliers, dimensionality reduction, and optimizing advanced models like random forest or neural networks to boost accuracy and uncover deeper insight.